Hi, hope you had a great day and hope you're having a great week. In today's tutorial, I'm going to be teaching you how to use future in Dart. Of course, to use that, you need to understand the differences between synchronous and asynchronous programming. So let's use an example. So let's say we have an operation to print. So what do you think this is going to print out? It's going to print out first output, then second output. Why? Because it's going step by step. It's coming from the first instruction going to the second instruction. Now, let's go to asynchronous. I pulled this up to explain it and make you understand it. So this is just a simple Google search and I saw this image will help me explain it. So now let's say we have a client device and a server. If we're using synchronous method, what happens is that we make a request, and once we make a request, because it's going synchronously, we have to wait for the server to respond. We suspend all operations, and once the server responds, we continue. In an asynchronous design, we can make a request, continue what we're doing, and once the server is ready, it gives us back the result. Sometimes you want to make request and you don't want the whole application to stop working. You want to make a request and ability to have work done. So normally in programming, you would need to have the ability to do asynchronous programming sometimes. So I'll use an example here using features to show you how to do asynchronous programming. So let's have a method. I'll call it long process. So what this long process is to represent a long operation. Let's say a method that requests some value from the internet. Of course, you know, an internet call, a network call can take some time, whether depending on the kind of complex operation going on or probably network speed. Some people might have a faster network than others, so obviously they won't get the results at the same time. So now, what is a feature in that? A feature represents the result of an asynchronous operation. So using this picture, once you make the request, it gives you back a feature, and that feature object returns the value once this operation is ready. So you can make an asynchronous operation and it gives you back a feature. That feature will have the potential value. It doesn't have the value yet, but once the time is ready, it gives you the value. I'll demonstrate that very soon. So a feature object represents the results of asynchronous operations to be completed later. So now, let's say we have a long process. Now this process is a long process, and let's sleep. So we decide we want to sleep a little. We import that.io. So this is a long process. So we come over here and we have first output, and then we have our long process. Let's sleep for 2 seconds and run this. So it outputs first value and waits for some time before the second value. Let's make this 5 seconds. As you can see, everything was stopped. So I'm just simulating a synchronous operation where a long operation stops the whole application from responding. But sometimes you don't want any operation to stop. You want the application to keep on running. So there you can use feature. That features. So in that you have async await, which is relatively newer than feature. It was added to that at 1.8. I think that's 1.8. But for you to understand that, we have to understand how features work first. So now let's use a feature instead of using this raw way of doing things. So we'll clear this, and this. So you have your long process and you have your main class. Now, once you have a process that returns a feature, let's go to the definition of a feature. Look here. A feature is an object. A feature of type T is an object which represents an asynchronous operation that produces a result of type T. So over here, this function will return a feature of type int. In order to use feature, you import that async. Yeah. So I'm supposed to return a feature of type int. So now we will simulate a delay here. Let's simulate a long process that takes time. In order to do that, we will say feature delay duration seconds 2. So we want to delay it for 2 seconds. But I desire to do more than this. I want it that once this feature is done, it should return me a value. Because my intention is that once the delay is done and it has finished simulating a slow network, it should also simulate giving me a result. That is assuming you want to get a result. So what is going to happen here is that I'm going to collect a variable here. So I'm going to collect a variable from the user and I name the parameter number. So if you want to execute a command after a delay, what you can do is this. So I say number times 2. So let's look at the definition of delayed. So in delayed, this is the code. You have the duration and computation. So the computation will be executed after the duration has passed. So this is going to be executed after 2 seconds. Had it been I didn't have any code to run, I'll just delay, but I'm simulating a network call. Now it is going to return a future. So I will say future int I'll call it multiple. So this is going to return a future. Now this doesn't have the answer yet, but once this is done, this is representing this, and I'm going to return it here. You can shorten this, of course, by doing this. I think you might like that. So we're returning a future of type int, and what this does is that it delays for some time, for 2 seconds, and once it's done, it returns the multiple. Multiplying this number times 2 returns that. So let's go to our main method. So now we call the long process. We're passing a value, I'm passing it. So we expect 8 to be multiplied times 2, 16. So we can come over here, and of course in that you can use var, but I'm just explicitly listing the type so to avoid any confusion in this tutorial. So future int value. So now this long process is returning a future. I'll update this later. This long process is returning a future, and this value is receiving the future. It doesn't have the value yet, but we can have callbacks that we can access once the value is ready. In order to do that, I can say value dot then give it, by using our lambda expression, print the multiple is S. So let me explain what is going on here. You have your long process, which is simulating a network call. It is returning a future of type int. Let's say I put 8. What I'm returning is a future that will later give me this value. So once this returns a future to this, I cannot use this callback to say, once this operation is ready and has the value, give me the value and let me work with it. So once the value is ready, print this. This is a lambda expression, and I can expand it like this. Instead of using a lambda expression, I can use this way of representing it to make it more presentable in case you're not conversant with lambda expressions. So we have our value and we use the dot then. So let's look at what then is. So it registers callback to be called when this feature completes. When the feature completes with a value, it returns the value here and you can use it to do what you want to do. So at this moment, once this is called, this feature is delayed for 2 seconds. Now, it is trying to simulate a long process. Some processes could take longer seconds. And after 2 seconds, I instructed it to reply and return this number times 2. So looking at this, it should return a value of 8 here times 2, which is 16. So 8 is passed here, it returns 8 times 2, passed in here, and the multiple is 16. Now, let us print calculating. So let's run the code and I'll explain why the code will appear the way it will. Did you see that? It printed out calculating before it printed out the multiple is 16. So look at this code in 2 parts. This part and this part. I told you that in asynchronous programming, using this diagram, we can be programming, make a request, and still continue working. Once the request is done, it returns back with the result and everything wasn't interrupted. So over here, I made a request for a long process. And I said, once the process is done, print this out. And I left this to be running and I came down and printed calculating. Because this long process is long, it has a delay. I made it 2 seconds delay. By the time it's been delayed, the code comes here and prints calculating. So that is why calculating was printed out first. And after some time, once this had finished, it returned the value. And then this code says once the value is ready, that's what then is. Value then, once the value is ready, print it out. Multiple is 16. So if we run it again, the multiple is 16. And I think that helps, or that explains features. We also have async await, which I will also explain. I'm going to talk on async and await. So in that, you have 2 options when you want to write code that depends on feature. Either you use async await or you use the feature API. I've taught you how to use feature. Now we're going to use async and await. Async and await. Async and await. Async and await. Okay. So now we have a long process. This is where our network call or complex calculation is going to be simulated. So let us delay this function. So we have future delayed duration. Let's say 4 seconds. So now what I just did was to delay this for 4 seconds. Now to make a function execute asynchronously, all you need to do is do this. Now int that cool. So once you call this function, it's going to execute asynchronously. Now we have used async. Now what of await? What does await do? In an asynchronous process, so let's imagine that this was a network call that was supposed to return a value, and then we had another network call. Let's imagine we had another network call here that used the value returned from here. That means that in as much as everything is executing asynchronously, we would want this to finish so that we can use the value returned here. Now, remember that because this whole function is executed asynchronously, even if there's a delay here, it is not going to delay our method, our function here. So I keep calling it method, used to that object-oriented programming. So in as much as there can be a delay, once in an asynchronous function, it doesn't affect our main function. So now we're going to say await. What does this do? What this does is saying, do not go further until this has completed. So first I will do this. Let's make this 2 seconds and print done with processing. So once we put await here, now mind you, you can't put await in a function unless it is an asynchronous function. So the two go together. So what this does is that this is an asynchronous function, and this is a delay. Now I'm assuming this is a network call. Now we could easily make a method, call it network call, and let's say return this. So now this network call is going to return the delayed feature. So let's imagine that it's a long network call. So we want to use the value from here, or we want to print done when the network call is actually done. Because the way asynchronous programming works, if I do not wait for this, it will run it, then keep going to the next value while this one is running, and this might print without this finishing. So once I say await, it means stop the whole asynchronous process and wait for this to finish before going to the next line. But in the moment this function is paused, it doesn't affect the main function. So let's demonstrate this. We don't really need this parameter. So let's have a long process, right? And I can say awaiting results. So look at this. So it printed awaiting results, and it now printed done with processing. So what happened here? It called long process. Long process is an asynchronous process. I taught you and explained what asynchronous process means. So it comes here, it says, oh, this is an asynchronous process. It goes over to the second line. Though the program still runs. Once this is done, it returns or prints out its value. So over here, long process is called an asynchronous operation. It has a network call and it waits for the network call to finish. And over here, it prints done with processing. But before it does that, because the network call will take some time, it has already printed awaiting results. So after printing this, it printed So what happens is that it came to this line, ran this function, came over here. Because this is going to take time, this is going to print out first here before it was done processing results. Now, there are some times where you actually want this to finish before this prints. So let's say this is actually going to be finish processing. Let's say that I want to print to the user that I'm done processing the result. So it will only be nice to say finish processing result and then say done with processing. I want, once it's done with processing, I might do some operations here, then I say finish processing results. So even though I want this to be run asynchronously, I want this to finish before going to the next line. What I do is use await. So I wait for this asynchronous operation. In order to do that, I told you a function must have this async keyword. It must be an asynchronous function to be able to have await. So once we have this, that means this must finish before this. So it's going to wait for long process to finish before it finally says I have finished processing the results. Before using this, it actually printed finish processing results before it finished the long process. But now I want to finish the long process before this. So when I run this, as you can see, it takes longer before any final text was printed because it came here and waited for the long process to finish, and it was done with processing before it finally finished printing the processing results. So that is a simple explanation of async and await. I will put some links to some materials that will help you understand below. If you know about JavaScript promises or Java's completable features, all these are very similar. If you'd like this video, please give it a thumbs up, and if you'd like to see more like this, please do subscribe. I will do more videos like this. I also have a plan to have Flutter tutorials. I guess you like Flutter. Most people that learn that like Flutter, and it's good to understand such concepts as features and async await. Have a great day.